Okay, so we're going to look at residual plots today. Okay, so if we remember, correlation coefficient we did the other day gives strength and direction. Okay, coefficient determination gives relative strength. Okay, so but there's something here. Sometimes like an low R squared value doesn't mean the model is rejected. Okay, there's another method to take a look at. It's called residual plots. So what a residual plot is a plot of residual values. So we have our line of best fit right here. Sorry, we have a chart right here with a line of best fit with our data points. Okay, and what a residual value is the vertical distance above or below the line of best fit from the data points. And we graph those on a graph. Okay, so it's the vertical distance above or below the data points. Okay. The model's a line or curve best fit. We should have low here. Okay. So anyways, I'm going to go through a couple of these and we're going to take a peek at it. So if you take a look at this one here, we can take a peek and you can see how the first point is pretty much on it. So there's no residual value. This one's half a point up. So it's a plus 0.5. This one's down 1.5. So it's minus 1.5 and this one is equal. Here is the graph of that residual. So the way the residual works is the vertical, the y-axis, is how far up or down off the line is. The x-axis matches the x-axis on your graph. Okay? The x-axis matches that. So if it were happen to be like 100, 200, 300, 400, you go from there. Then we plot where the residual is. So here, that first dot's right in the line, so we put a dot there. Second dot was half up, so it's going to go half above the line. Third dot was 1.5 down, so we go put a spot 1.5 down. Fourth was on the line. Okay, it's very good because you can see outliers as you do this. Because if I had dots, I'm just going to plug them in here. If we had a whole bunch like this, all the way around it, and then we had one way out here, you can kind of see that one outlier there. But it also lets you see when you have your model wrong. So I did a linear line of best fit for this one. Then I plotted the residual plots. You can see there's a pattern here where it's actually making a curve. So you might know, hey, I have the wrong residual of it. I did linear, it should be parabolic. So if we look at these ones here, the top is the line of best fit. So we have a line going down, okay, with the dots around it. Then the bottom here is a residual plot. Like for example, this dot here is right on the line, this is right on the line. This one's above, we got a dot above. When we go here, there's one below, there's the one below. So it goes up or down, so there's two above here, there's two above there. And we'll graph as we go here. Now this one here, you can see here, it kind of goes below, above, and then below. So you can see it on here, where we go below, we go above and below. So you can kind of see residuals making a pattern there. And here we have a weak correlation. You can see how the dots are all spread out here, and the dots are above and below here. So that's the gist of how to do a residual plot. So let's get down to the nitty-gritty here. So the first one here, I have, let's figure out the very first thing let's figure out how much these are worth. So it looks like this is 12, 14, 16, 18. So every one of these squares is 2. So as I look through this, and I messed this up earlier, this should be, I'm going to put 1. This should be 0, this should be 1, 2, 3, 4, So if I go to my first dot here on 0, I measure the space between here and here. And that is minus 2.5. So minus 3. So it's 3 numbers down, so I'd write a minus 3 here. Here, it's 1 chunk down, so that's minus 2. Minus 2. I'm going to change the blue here. This would be 2, 4, 6. It's 6 vertical distance above, so it's 6 above. I'm going to go up 2 here, so that's a plus 2. We're going down again, it's 1.5. That's minus 3. And then, Moxie. Oh, sorry, I thought my dog was eating something. And here, we're up 1.5, so that's plus 3. And I'm saying that because every one of these here is worth 2. So then, one second, my dog's eating something. Alright, so now I go down here. You make your residual plot kind of like a T here. And I'm going to go 0, 1, 2, 3, 4, and 5. Yes, you usually put 0 right here. Usually 0 is going to be right there, but I'm not going to put it so you can see it. Now, I know I have to go up to 6. So I'm going to go by, let's go by 2s. I make that 3. Let's go by 1s. 3, 4, 5, 6. So 1, 2. Then we have to go on the same on the way down. So that's minus 3. So it'd be minus 1, minus 2, minus 4, minus 5, minus 6. Okay? So then let's graph all this. So at 0, I have a minus 3. So I'm going to go down here. I'm going to put a dot right at minus 3. At 1, it's minus 2. So I'm putting a dot here. At 2, it's 6. It's 6. So I'm going to put it up here. And then at 3, it's 2. So it's going to go right there. Then at 4, it's negative 3. So I'm going to go here. And 5, it's plus 3. So I'm going to put a dot right there. So there's my residual plot. Okay? So I've charted how far above or below the dots are from the line. Okay? And here we can kind of see the spread of the data. You can see the strength of it. You can kind of see, oh, that may there be an outlier. So it kind of gives the pattern we go. So let's do another one here. Once again, I got to change my numbers because I messed up. 0, 1, 2, 3, 4, and 5. So once again, these are all worth 2. So it's 2, 4, 6, 8. So I know 1 square is worth 2. So if I go for my line here, that's minus 3 there. This here, I'm going to say is a plus 0.5. This here is going to be a plus 1. Oh, I should be writing this down here. Minus 3 plus 0.5 plus 1. This here is, that's 3.5, minus 3.5, let's say. This here is 2, 4, 6, 8, minus 8, and plus 2.5. Okay? So I've measured the vertical distance between the lines. Then I go here. I'm still going to go 0, 1, 2, 3, 4, and 5. Now I have to go all the way to 8. So I'm going to put a 4 here and an 8 here. Negative 4, negative 8. We're going to go 1, 2, 3. 5, 6, 7. 1, 2, 3, 5, 6, 7. So my first one is at minus 3. It's important you put the minus there so I know where it's going. So I'm going to put that at minus 3 right there. This one's at 1 is plus a half. It's going to be really close there. 2 is plus 1, a little bit further up. 3 is negative 3.5. So I'm a little bit right here, let's say. Negative 8, I'm all the way down here. And plus 2.5 is going to be about there. So this is really easy to see after I look at it. I can really identify this as my outlier. Because everything else is kind of in this area right here, looking good. But that's my outlier right there. Okay? Is that my only one? Now, one thing you could have here, I'm going to add this to this. Let's say on this one here, I had one right here. I had a dot right there. So that's a plus 2. So I may have 2 points at one spot. I may have another 4 and a plus 2. So when I was at 4, I would put one right there. There's my dot I added. So it's okay to have multiple residual plots in one spot. Okay? And that's how you make a residual plot. The main thing is we're graphing the vertical distance between the line of best fit and our data point. Second thing is here, our x-axis goes up just like the x-axis on a graph. And here we have to have the same scale on the positive as we do on the negative. Usually what I do is I pick my furthest one away and I set my scale as such. And it's just on a T graph like this. And it can go for however long you want. Mine I just copied off the internet to make it easier. Okay. I'd recommend making this chart before. It just helps you organize your numbers as you transfer them over. Okay, so you have practice in your folder and you should be good to go. Actually, you're going to get practice handed out. Okay, you should be good to go and have a great day.